Good morning, everyone. Thank you for coming. I know it's early on Wednesday, so I appreciate all of you showing up. Today, we're going to be talking about AppStream 2.0. I'll do a quick overview of what the service is, do a demo as well, and then you'll hear from Ian Chadwick from GE Renewables to talk about their journey with AppStream and enabling their application owners. And then after that, I'll do a little bit more discussion about one of the other use cases with AppStream for software vendors. And then I'll hand it over to Jamil from Multiview Corporation to talk about their journey of SaaSifying their traditionally delivered client-server application. I should have flipped to the title slide. So before we get started, how many of you are familiar with application streaming in general, just by a show of hands? All right, so I can probably breeze through the application streaming part. How many of you already have an application streaming technology deployed? OK, cool. And then how many of you are software vendors looking to how to use AppStream to deliver software to external customers? A little bit, cool. All right, let's dive right into it. So what is AppStream? AppStream is a fully managed application streaming service. There's two parts to this. Basically, all of you are already familiar with application streaming, so I'll just breeze through that real quick. And then I'll go into what is really the fully managed component, and what does that mean for AppStream. So as you're all already familiar with application streaming, it's basically the process by which your traditionally delivered desktop application is running in the cloud, co-located with your backend servers, files, other data warehouse, visualization tools, and all these things. They're all running there next to your desktop application, which gives you high bandwidth, low latency access to your data. And so all that's being delivered to your end users is encrypted pixels of it. And it's cheaper to send the encrypted pixels of the data than it is the data itself. And so there's quite a few benefits for this. So if you think of, there's a security benefit from this, where there's nothing actually running on the user's local device. There's no data residing there. Everything is secured within the cloud. So moving into more of the fully managed side of it. So AppStream is fully managed. If you think about your traditional application streaming technology, there's databases, network appliances, load balancers, physical hardware if it's on-prem, administration servers, all of these other components that you have to deploy and manage yourself. With AppStream, there's none of that. AppStream manages all of that infrastructure that you traditionally had to deploy in your on-premise or AWS environment for you, and you don't have to worry about any of it. We maintain it, and we keep it running for you. It's secure by default. All of the applications and data are remaining on the AWS cloud. So you don't have to worry about data moving back to the user's local device. If the user's device gets stolen, you don't have to worry about leaving it in a coffee shop or anything like that. It's all remaining within AWS. AppStream is a fully non-persistent resource with some persistent capabilities. What that means is at the end of the user's session, we terminate the EC2 instance. And so anything that they had running, maybe if they got some malware on it or something along those lines, none of it persists for their next session. The instance is totally terminated. And it's encrypted end to end. So the pixel stream that the user is getting is AES 256 encrypted, and so you don't have to worry about people packet sniffing or anything like this as it traverses the internet. And you can scale on demand. So AppStream has 9 AWS regions globally. New this year is the Seoul region and US GovCloud West. So you can deploy AppStream to the region that's closest to your users to provide them the right experience and performance that you want, while also having a secondary region if you need it for high availability, disaster recovery, or anything like that. As well, AppStream integrates with application autoscaling. And so you can use autoscaling rules and policies to make sure that you're provisioning the right resources at the right time. You can provision based on just adding or removing a number of instances. You can use scheduled scaling, which allows you to basically manage your boot storm. So at 8 a.m., I know I want to have 500 instances. And then at 6 p.m., I want to shrink it back down to 30. You can manage that to manage your cost. Also new this year is target tracking scaling. So one of the challenges we've heard from customers is, hey, I have to maintain a set buffer capacity set if I have a boot storm come in or unexpected high demand from snowpocalypse or something along those lines. I have to make sure that there's capacity there. With target tracking, you can say I want to maintain 85% capacity utilization. And application autoscaling will automatically figure out how many instances to add or remove for you, really removing the guesswork of how do I need to set up my scaling policies. Much like all the other AWS services, AppStream is pay-as-you-go. Unlike the traditional application streaming technologies, there's no long-term contracts. There's no licensing that you need to purchase, none of that. You only pay for what you provision and when you provision it. So we have customers that are using AppStream for training sessions. If you think about training sessions, you're only going to use the environment for 2 to 3 days, and then you're done. And with AppStream, you can provision the infrastructure for those 2 to 3 days and then turn it off, and you're not paying for it ever again until you need the infrastructure again. And with scaling policies, again, you're really controlling the cost as you get it. AppStream integrates with your existing infrastructure and your existing IT. So you can connect your network. AppStream is connected to your VPC. You can launch resources within your VPC and apply the security groups that you're used to and other network routing rules and other network policies that you would expect. Identity, AppStream supports SAML 2.0 federation. So for the enterprise side, if you have AWS SSO, ADFS, Ping, Okta, Shibboleth, Canvas now for the educational customers, you can use that to maintain your existing identity. So you don't have to create a secondary identity entitlement process in order to use AppStream. You can just federate. For the software vendors in the room, if you're familiar with S3 pre-signed URLs, you can generate a pre-signed URL to provide access to AppStream, which basically means that if you have your own identity system that's not SAML compliant, you can still provide access to AppStream. Since AppStream is launched in your VPC, you can provide the same level of access to your storage, Windows file shares, Amazon FSx, other data repositories that you have, as well. AppStream has native integration with Google Drive and Microsoft OneDrive. So if you have all those environments already set up, you can enable your users to sync those within AppStream. And then, again, because it is within your network, you can attach it to any databases and servers that you have and apply separate security boundaries around it. And then AppStream enables you to simplify your app delivery. Because AppStream is an image-based system, which I'll walk through in just a second, every user is getting the exact same version of the application. You don't need to worry about the user install their own version of it or change the configuration file or something and now it's no longer working, because every time they log in, they're getting the version that you as the administrator had provided to them in the configuration that you want them to have. So you don't need to worry about sprawl. You don't have to worry about Windows patches anymore. You patch the image. Every user will get it as soon as you apply it to the fleet. AppStream is managed through code. So again, very similar to other AWS services, you can use our rich SDK and command line interface in order to manage your environment, as well as use CloudFormation. So you can very quickly programmatically stamp out environments that you need in different regions, or you can create your own automation using our SDKs. Also new this year is we have on-instance image builder APIs. So one of the feedback that we got from customers is, hey, with the image builder process, I have to manually go through the GUI, install the application manually, create the image manually. I really want to be able to programmatically manage this. And so we made available a command line interface on the image builder that enables you to programmatically manage the environment. You can apply your branding. So this allows when your user lands on the AppStream catalog to see a common look and feel that they would expect when they land on it. So you can apply your GE logo, for example, to the catalog. And so when your user lands on it, it looks like they're actually landing in a GE environment versus some third-party service that they're not aware of. You can apply your footer links and all these other things that really enable the end user to feel like it's a service that is being provided by their company. AppStream has flexible hardware types. So we have a variety of instance types and sizes to really allow you to right-size your workload based on what you're doing. So if you're delivering something like SAP GUI, that's a much smaller workload, or even a Chrome browser, you really need just this standard.medium instance type, which starts at 10 cents per hour in the US East region. But on the flip side, if you're doing like an HPC-style workload with Teamcenter or Siemens NX or MATLAB, and you need a GPU to do CUDA workloads, we have the Graphics Pro instance, which makes the Tesla M60 available. Or if you're doing more of other SolidWorks workloads, we have a graphics design instance that's based on the AMD instance family that starts at 25 cents per instance per hour in US East 1. Also new this year is the EC2 Z1D instance type that we've made available. This was a customer ask because the Z1D is a memory optimized instance with a super fast single thread. So it goes up to 4 gigahertz. So you have workloads that need a really fast CPU. We've made that available. So in a nutshell of how does the overall AppStream process work if you want to onboard. So we have what we call a AppStream image builder, which is basically just a persistent EC2 instance that you can connect through your browser. And you can upload your installers, or if you have them on a network share or an S3 or something along those lines, you can install them how you would on any desktop computer similar to your laptop. Pull down the installer, install it, configure it the way you normally would, and then launch our wizard to specify which applications the user can access and launch. After that, you then create the AppStream image, and then you create the fleet off of that image. In parallel with that fleet being created, you can then you can connect your identity system. So you can enable your SAML 2.0 identity federation to provide access to your end users, connect it to your VPC and other storage if you want to enable Google Drive or OneDrive. It's all very simple through the AppStream Management Console, or you can use it through the APIs. Alternatively, if you want to do it for proof of concepts or you just need a quick environment, AppStream does provide built-in solutions for these things. We do have the user pool feature, which is a built-in identity system, as well as persistent storage. So you can enable S3 home folders or app settings persistence in order, which uses S3 as the storage to enable some persistence capabilities for your end users. So then you create the fleet, and then you entitle your users to the fleet through your identity system, and then your users securely access their desktop applications through a browser on any computer, which I will show in the next slide. So new this year, cool. So new this year is we've enabled tablet support and gesture support. So we had asks from customers that, hey, we want to provide sort of intermittent access to our applications from a tablet using gestures that we use, or we're used to. So I'm going to do 2 demos. The first demo is more of the enterprise-style use case using AWS SSO as the SAML identity provider. I've already got my credentials entered because I don't want to show you guys my password. Go ahead and sign in. OK. So now this shows me all of the resources that I've entitled. This would be a very similar process if you're using something like Ping, Okta, that have an application catalog associated with it. The user will see whatever resources the admin has entitled to them in the catalog. I'll go ahead and launch our graphic stack. I need like some background music. So on the stack, these are all the applications that my administrator has made available to me. I can choose which application I want to launch. I will launch SolidWorks. This instance is our graphics design instance, which has an AMD GPU associated with it, which is enabling applications like Blender and SolidWorks to work. Go ahead and accept the EULA. So I'll go ahead and select my Raspberry Pi model. So for example, let's say I wanted to go to a meeting, and I wanted to be able to show off my 3D model that I'd been working on to my coworkers or my manager. I don't have to bring my bulky engineering workstation anymore. Now I can just bring my iPad. And so it's much easier. I can select things. I can modify it. I don't know how to use SolidWorks, but I can rotate. Multi-finger gesture support works. And so I can sort of use this in a way that's enabled for my end users. But all the other standard AppStream functionality is still there. So if I need to launch other applications, I can launch whatever I need. I can manage it between the 2 applications. So it provides sort of a very rich experience straight from the browser on the device. So there's no application to install. There's no plugins or anything like that to manage. It's a full HTML5 compliant stream. And the nice thing about that is it's very firewall and proxy friendly. So you don't have to worry about, do I have to open up extra ports or anything like that. If you have an existing proxy to the internet, it works perfectly for that. I can go into full screen mode and just provide a full screen experience with it. So it provides overall a very rich experience, if I don't break it. Provides a rich experience for the end user. You can trigger like the on-screen keyboard to be able to pass in keystrokes. Cool. So the other demo that I want to show off is a new feature that we launched this year for more tailored for the software vendor side of the house, which enables you to provide an embedded experience within a web portal. So previously, customers or software vendors want to have their Windows application alongside of their web portal. And AppStream now enables this with our embeddable features. So we provide a JavaScript object which allows you to control the AppStream experience programmatically through JavaScript and manage the experience. So here's the example. And all of this code that I'm showing is going to be publicly released. And parts of this are already there with our software vendor workshop to help bootstrap you with taking advantage of AppStream as part of your web portal. So the example that I'm going to use here is you can basically say, these are all files that are stored in S3, and I want to launch them in Blender. And so I can just go ahead and hit submit. In the background, it's calling API gateway to Lambda to generate a pre-signed URL for me, and then it's redirecting me into AppStream. And if you notice, now I'm still within my web portal. The AppStream toolbar is gone because the administrator has decided, hey, this user really doesn't need it. And now I have Blender sitting here. And if you imagine, you can put whatever information and material you want around this. So if you want to do this as for training material, you can put your training material on the top or bottom, so your user doesn't have to flip back and forth between a booklet or another tab or something like that to do their training. They can see it very seamless. And because this instance is also graphics enabled with an AMD GPU, I can provide sort of that rich experience from a device that doesn't have a GPU. So think of Chromebooks, Ultrabooks, any device that really can now have access to the full power of an EC2 instance that it normally wouldn't. Cool. Now, flipping back to the slides. OK, so I'm going to talk briefly about the use cases, and then we'll bring up Jamil and Ian after that. So on the enterprise side, what we see for why customers are using AppStream, it's to deliver virtualized business and graphics applications. And the reasons for that are security. You can apply a different security boundary around your Windows application than what you can on your physical device. You don't need to worry about MDM and other tools, all that, to manage it, because nothing is actually residing on the local device. It's all remaining within the cloud. If the user's device gets stolen, no concerns there. Management, all the applications are centrally managed. You don't have to use other application deployment tools or patches or anything like that. It's all managed centrally through the image process. Performance, apps and data are co-located. So you have high bandwidth, low latency access to the back-end servers that your users are using for this. So if you think of like a Redshift cluster that has terabytes or petabytes of data, you can provide access to the SQL Workbench or Python or R and RStudio and provide them the experience as though they're sitting in the AWS region with a wire directly into the Redshift cluster. Agility, because it is all HTML5 based, you can use any computer that has an HTML5 compliant browser to access and stream Windows applications, scale on demand using our auto-scaling policies, and global reach through the 9 different regions that we have. And the example applications that we see are things like Siemens NX, Autodesk AutoCAD, MathWorks, MATLAB, SAP GUI, and things like this. Veolia is using AppStream as part of their overall journey to migrate to web-based apps for the applications that they still need that don't have web app equivalents. They're delivering Windows applications to Chromebooks. So as part of their overall journey, enabling remaining productivity by delivering those Windows applications to a Chromebook. Vanguard is using AppStream to provide essentially a bastion host into their resources. So the developers have the ability to access their resources securely within the AWS environment without any worry about data coming back out of that environment. And with that, I will hand it over to Ian from GE to talk about the GE story.
Thank you, Marley. So good morning, everybody. For those you don't know me, I'm Ian Chadwick. I'm a solution architect from General Electric. And I've been moving applications to the cloud for the past 4 years now. So just a quick show of hands. Who's heard of General Electric? OK. Who's heard of GE Renewable Energies? Good. Well, for those of you who haven't heard of General Electric, the next slide, GE Renewable Energies, the next slide will tell you a bit more about it. And for those of you who know about it, hopefully you'll pick up a few tidbits. So obviously, General Electric's been around for about 127 years now, so it's quite famous. However, Renewable Energies, even though some of its business units have been operating for about 80 years, was only formed about 4 years ago now in 2015. So today it consists of 6 business units that we have up here. We have onshore and offshore wind, which are on the far right-hand side. And they have about 42,000 turbines that we've actually delivered around the world today. And we're currently building the world's largest and most powerful one in Rotterdam. And to give you an idea of the size of this thing, if you take the Statue of Liberty and put it on top, one on top of the other, on top of the other, so 3 Statues of Liberty, it gives you an idea just how big this turbine is. Following on from that, we have I can't read from the slide. We have LM Wind. So LM Wind are a Danish company bought in 2017, and they actually make the large blades that go onto these turbines. So these are all made by hand, and some of these can be up to 207 meters long. To give you an idea of this, the average American football field is 50 foot short of this. These things are huge. So once they're made, they're stuck together and they're transported out. And believe it or not, the company started out in 1940 and they actually started building wooden furniture and caravans. So you can see they've come a long way since then. After that, we've got hydro. So there's one of our examples not far from here, the Hoover Dam. Hydro, they make the turbines, generators that provide the electricity. And not only do they do classic solutions, which are taking water from dams or from rivers and providing electricity, they also have something called pumped storage, which in simple terms is a huge battery. What they do is when there's excess electricity, they take this from the grid and they pump water from a reservoir on the bottom all the way to a reservoir on the top. When we have peak demands or when the sun's not shining or when there's not enough wind, we can then take that water, we can pass it back through there and generate electricity. This means we can keep houses supplied with clean electricity throughout the day. Following on to this, we have grid solutions. And grid solutions, they help us bring the electricity from the power stations through to the substations and onto your homes. They build transformers, switches, control systems that handle sometimes up to 120,000 kilovolts. So this is obviously a little bit more than we get for your outlets that you have in your house. At the end, we've got hybrid solutions. So hybrids, they bring all this technology together. So they have solar, they have wind, we have battery power, we have the control systems, generators, all this. So bringing this all together, we can help provide clean energy to as many homes as we can. So our cloud journey, as I mentioned, started in 2015. Now, GE Renewable Engineers is an enterprise-sized company, but being created in 2015, we still have this sort of mentality of being sort of a startup. We still want to be agile. We still want to be conscious of costs and things. And AWS is helping us to do that with all the different services it has. So in 2017, our current CIO arrived, and in 2018, it quickly realized that cloud was the way to go. And she started our cloud initiative to ramp that up. And we had a couple of objectives there. We obviously needed to reduce the cost. We wanted to integrate some of the businesses that you've seen we've taken on. And she also set this cloud target of adopting 80% of our applications in the cloud by 2021. So we've moved a lot of our applications across there now. Just to give you an idea of where we've come from. In 2018, we had 2 VPCs, 10 servers, and I think 2 databases. Today, we're now hosting 20 VPCs, over 600 servers, and 140 databases. This is in less than 2 years. To manage this and to help with operations here, the teams and the operations, automation, and security teams, they've increased 5-fold. We've gone from 2 pizza teams to a lot of pizza teams. So we've done a lot of work over this time. Okay. So I'm going to walk through one of the applications that we took today into Upstream. So this is a tool called Engineering Management Tool. It was a tool that was created in 2014 in Spain, and it's this sort of classic IT story. The business build an application, it's in Excel, it's in Word, it's in Access, and this thing gets developed and developed and developed, and eventually after a couple of years becomes this huge unmanageable collection of code and data, and normally reaches a critical mass of unmanageability, at which point it's sort of handed over to the IT team with the post-it on it. Can you please fix this and manage it for us? So I guess you've all got one somewhere around in your business. We didn't actually get to this critical mass. The team actually came and spoke to us before we got there. And as I was saying, this was built in 2014. It started in Spain, managing 40 people. In the following years, in 2014, 2017, this was a raging success. It got taken on by 8 other sites. We went from 1 single installation out to 9 installations and 800 people. So this is now getting a very, very big application. And finally, in 2017, there was a change in the organization. the engineering organization became global. So this meant engineers from the different sites, from different projects, now had to work across all the different sites and all the different projects. And this made using this application extremely complicated. And trying to do reports across all these different sites really didn't work. So something had to change. So this is why they came to us and said, we need help now. How can we improve this application? Now, the obvious solution is here. I think Morali mentioned earlier on. Let's put a web interface on the front of it. Let's put a nice database in there, single consolidated database. Let's run this on serverless architecture. And this is still the goal today. This is what we want to do. Unfortunately, the teams that developed this have other commitments and couldn't provide this within timescales that was going to be acceptable to the business. So what they were looking for was a temporary solution to allow them time to get this developed. So what they were looking for, we're looking for a solution that's scalable. It can handle 800 people. It has to work from around the world. They don't want us to spend any capital expenditure. We can't put investment. We can't go buy licenses. This is the throwaway product later on. And we've got to keep 800 users happy. So this is where we start looking towards AppStream to help us out. The solution in general is we're going to take the 9 databases, we're going to bring it to one site, we're going to use AppStream for the front end. One of the first things that we looked at was this application uses local authentication, and with the changes today, our security running rules don't allow us to have this. We needed to find a solution for this. So what we did was we took the SAML login page that you have inside of AWS, we connected it to the GE identity provider. So this is called the GE SSO. With this, we managed to have a primary authentication method that hooked into our IDM systems, our identity management systems, and gave us a holistic user management. Security happy, end users were happy, as the SSO system we have today in GE is connected to about 10,000 other applications. So this wasn't anything strange to normal users. In addition, if they'd already connected to a web application in a day, they didn't even see the login page. And all this for no extra cost. As I mentioned, we brought the data, the code, and everything back. We put the code for the users onto the AppStream solution. We brought the files, we brought the reporting and the databases back onto a simple EC2 unit. What this would allow the developers to do is, as they're transitioning towards this web interface and they're consolidating databases, they can make these updates very quickly, very simply, in one single place. We have a sort of notion of self-service. We use catalogs, service catalog. This can help our operations teams to deploy frequently requested services like EC2, storage, etc. But it can also help us set up environments like AppStream. We have Tata Consulting automation engineers here who helped us define what we wanted to do, make the products, and then deploy the IAM roles for users, for the application owners. There's 3 buckets, all this going to create the AppStream environment. And finally, we'll see a little bit more about this later. We've put in place IAM roles. We've tried to give the application owners the freedom to do as much as they can within reason within these environments, so they can keep rolling out their applications. We don't want to have this stop, start, stop, start. So you'll see later how the applications have a lot of freedom inside of our environments, albeit very controlled. But if you're like me, I like playing with new toys and things and new features, and AppStream was a great way of innovating. But innovation in isolation can often lead to some architectures which are insecure or very costly. So during the development phase, we worked hand in hand with the security teams. We also made sure we gave transparent cost estimates to our business. And by encapsulating this innovation inside cost and inside security, we're now providing not only this, but other solutions which are cost-effective, secure, and allow us the business to function. So managing scale. As I mentioned earlier, we've got 800 users across 6 time zones. So before starting to put AppStream in place, we needed to understand how big we needed to size our fleets. So I went to talk to the application owner and said, can you tell me, how do your users connect? When do they connect? What do they do? And he went, yeah, it's a good question. I don't know. So we spent time with him looking into that application, trying to gather this information to find out how things were working. And what we found out was, even though the users are spread across 6 time zones, they're actually grouped into 3 continents. If you think about it, we've got Asia, Europe, and the Americas. So about 9 o'clock in the morning in Asia, everybody comes into work, they start using the application. They'll continue. The Europeans will come to work, and they'll come along. And then finally, you'll have the Americans joining later in the day. So you'll have peaks coming up, and in the middle of the day, we found out we were using anywhere between 40 to 50 concurrent connections at the time. So we took all this, and this gave us a user profile. So we knew what the users were doing throughout the day on a weekly, monthly basis. So we then took this and started looking at what methods can we use to make sure that our upstream fleets can be available when these people come into work. So this is a graph here. This is taken straight off the upstream console. So I haven't touched this at all. I'll just walk you through it a little bit. On the one side, you've got the instances. Along the bottom, there's a time scale. And then the blue line at the top. So this is actually what we're requesting upstream to provide us. So you can see the big peaks that it jumps up and then comes down. So the blue line is what we asked for. The purple line is what upstream actually provides. These are the number of servers that it's spun up behind the scenes that are waiting to be used. And finally, underneath, you can see the orange line. So this is what's being used by our users. And the name of the game is to try and get these two together. Get them as close as we can so we're not having instances that aren't being used, but we need to avoid any out-of-resource errors. So there is one there in the middle, that sort of green line there. That shows that we had users who came along and didn't have any instances. So it's a game, we have to try. We put an initial plan together at the beginning of this year for our users, and we reviewed this over a period of 2 months every week to try and change this and fine-tune this. Now, in order to put this in place, we use some of the features within inside of upstream. First of which is the scheduling. So we can schedule additional instances to be spun up. There is a lead time for spinning up instances on upstream, and to compensate for this, because we've got our profile, we know what our user's doing, you can see that we jump up the amount of instances available, and upstream follows. So if we have repetitive, large changes in the loads, we can use this to anticipate those and make sure that we have instances available. When we come towards the fine-tuning though, we've used 3 policies. So we've got 2 scale-out policies, which you can see working here, bringing the upstream fleets up to size. So the first one triggers at about 75% usage. So as the fleets start to get used, it will start adding on instances slowly. Sometimes if we do have a large load coming along, as you see in the middle there, we trigger the second one. The second policy is a bit more aggressive, and it will add about 5 or 10 instances afterwards. So this is cumulative. This will add on to what is already going there. So between the scheduling, the 2 scale-up policies, we're handling the majority of requests that are coming in through the day. Again, this is for 800 users coming in on a constant basis. These machines are being added and created all the time. And finally, we have the third policy, which is scale-in policy, which you can see on the right-hand side, and that's going to bring the fleets nicely down. In general, as you can see here, we have somewhere between 40 to 50 instances in the middle of the day. The weekends, we can be down to sort of 4 or 5. So you can see the range of uses this application has. So, summarize a bit there, by understanding how our application is used, we can manage the costs. Frictionless IT. So, as I mentioned earlier, we're a sort of agile, innovative thing. We're always looking to change, to improve our processes. We're already looking for ways to remove what I call value-added tasks. Now, the non-value-added task for me is, I don't want somebody calling me up and asking, can I switch my EC2 on? I'll go to the console, switch it on. Okay, He's got what he wanted, but what did I add to that? Make it even more maybe ridiculous. Could you imagine somebody coming in the morning and phoning the IT department up, can you switch my PC on? These things are adding no value to the business, and we try to get rid of them. So our frictionless IT, friction, if you want, in the physical world, is a force that's stopping progress. For us in the IT, friction is the continual handover between different teams. We hand it over, we wait, we get something done, we hand it back again. This is all slowing us down. So this sounds good, but what can we do to reduce this? We looked at ways of giving our application owners as much freedom as they could within the AWS environment without impacting either the larger infrastructure inside the VPC or other applications. In order to do this, one of the first things we did is we needed to identify all the resources of a single application. So anything that you will see inside of our VPCs either has a name or a tag which is attached to a specific number, or as we call it, a unique identifier. Once we have these in place, we can put in place what we call role-based access control. That is, we put in IMA policies that give users the rights to do things, but is limited to only their application. So now they can access they can do anything they want, but only to their applications. In addition, we have two different environments. We have the non-production environment, production environment. Non-production, we let them do a little bit more. They're free to test out service and things. Whereas in the production environment, this is where we protect them and make sure that we can run these applications on a day-to-day basis. Put it another way, non-production, they can create, they can modify, they can delete, they can change. Inside of production, they can only modify what already exists. Once all this has been put in place, we can now hand all this over to the application owner. The cloud team can go off for a coffee, and the application owner can go through, they can create their image builder, they can install their software, create their images, build the fleets and the stacks, and ultimately get to the point of testing in UAT. Any regression that is found, any problems can very quickly be passed back towards the application owner, and he's completely free to modify this again. So this all lends itself to the agile methodology where we're doing many iterations a day. We're not building a big application, then presenting it and coming back with a whole list of things to change. We can do this quickly. And as I say, this is all very frictionless. We're not having to get involved. Obviously, the cloud team is still there to provide support if need be, but where we can, we leave the hands off, we let people get on with their work. Seamless deployment. Once the application owner is happy, they have a secure, fully tested image. We wanted a one-click, but we got 2 clicks. He can deploy the image 2 clicks. He shares the image from the production environment into the production environment. He goes to the fleet. He changes over the image. That's now live. It took him 2 clicks. If there are any problems, if there is anything that's found out as a problem, there is always the image there, the old image there. He can switch back. So by empowering our application owners with as much freedom as they can, I hope you can see here they can go from development right the way to production, hopefully with no help or intervention from anybody else in the cloud team. We didn't stop there though. We went on to look at sort of other ways. Oops, sorry, on slides. Thank you, Morali. I'll hand over to you. Thank you.
For showing how you can empower your application owners and really change your workflow. We do have another session at 1:45 later with GE Power going into more detail about how to empower the application owner and how you can use our APIs to build an enterprise application onboarding workflow, very similar to what Ian has built. So shifting gears a little bit for the software vendor side of the house, and some of the enterprises that we've been working with also have a software delivery component, so this is still interesting. So we see software vendors using AppStream to deliver online trials, training, and SaaSifying their application. So on the trials and demo side, we have SolidWorks, who has their traditionally delivered large installable, you have to download it from their website, install it, configure it, just to even get started seeing what SolidWorks is about. And so now they're using AppStream to deliver a trial without requiring any installation or configuration. You go to their website, you sign up for it, you can immediately get started playing with SolidWorks within the browser to get a feel for it without having to do anything. Super frictionless. So you don't have to worry about having to go through this entire process. Training workshops is another big one. I mentioned MathWorks earlier. So MathWorks with the MATLAB software previously would have to carry around these large engineering workstations or engineering laptops in order to provide CUDA workloads or a CUDA environment for these applications. Now with AppStream, they're able to spin up an environment for the 2 or 3 days of their training workshop or their certification environment, and they only need it when they're doing it. So as soon as they're done, they turn it off and they're not paying for anything. Finally, we see ISVs moving towards SaaSifying the traditional client-server application using AppStream. So before, you'd have to go sell a perpetual license and then a support contract, and the customer would then have to go install it themselves. If it was a client-server application, they'd have to go install the server backend and manage it all themselves. Now with AppStream, you can make this a totally SaaS-based environment where you're managing both the client side as well as the server side. And this really accelerates the time it takes for your customers to upgrade. Now you're not worried about, oh, the customer is 5 years back because they haven't chosen to buy a new software version. You can manage it for them. And so to talk about one of those SaaSification journeys, I'd like to introduce you to Jamil from Multiview Financial, who will talk about their journey of delivering their application as a SaaS using AppStream.
Good morning, everyone. Thank you, Murali. Welcome to Las Vegas. Welcome to reInvent. Thanks for coming to our session today. My name is Jamil El-Ghazel. I'm part of the technology services team at Multiview Financial Software. A little bit about me and my company. We're based out of Ottawa, Ontario, Canada. And Ottawa is a great city, traditionally has a great pool of R&D researchers that have catered to the federal government over the last 100 years. And Ottawa consistently ranks high on livability indexes globally. Now, if you can't tell, I am proud of my city, but also very proud of Multiview and what we've done, and I'd like to tell you about that today. Multiview builds accounting and financial management software. Okay? Our clients are spread across North America, both Canada and the United States, and our core financials product really helps them get insights into their financial positions live in real time. And that's one of the things that stands out from Multiview compared to our competitors is we can offer our clients deep insights live into their financial positions. And as you know, knowledge is power, as opposed to some of our competing players in the space where the information is days, sometimes weeks or months behind. So the reason I'm here today is to tell you about AppStream 2.0, our selection process of why we landed on AppStream, and the use case. Now that's really the official reason, but there's a real story underneath the surface, and that story is about how an established company like Multiview, who has been in business since 1990, reinvented itself, pun intended, to go from a traditional sales model of selling software to now having transformed into a SaaS business by way of AWS products and services. So let's get started. So Multiview, of course, as I said, has been in business since 1990. We've had to renew ourselves throughout those 3 decades, next year being our 30th anniversary. We have an existing product. It's a Win32 application. It's installed on-premise. We install remotely on the client's server that they would stand up for us, and then we would provide them a Windows-based application. And that client-server product has been reiterated over the years and worked very well for us and our clients. But over the last couple of years, 5 years ago or so, 6 years ago, we began to see demand from the marketplace to be able to offer and complement our existing product line with a cloud version of the software. And as we know, that shift has taken place and continues to take place today. Currently, it's almost 19 out of 20 new deals for us is cloud. So the market truly has shifted. No one is interested in on-prem software anymore, pretty much. And so AWS serves us very well. So we came up with a plan. Let's build a cloud-based application to deploy to our clients over the internet. And so began the journey. So when we looked at our options, it was really two options. We can rebuild Multiview from the ground up as a pure web application, or we knew that there were ways that we could use a technology to stream that Windows app, the existing Windows app, over the internet to end users. So comparing the two, now this selection process that I'm about to go through, of course, simplifies a very long journey, but for your benefit, I've summarized it into this one slide. So rebuilding as a web app, of course, lots of dev time. And for a company like Multiview, who is tooled up to develop in one way, it would require new hires, new talent. Of course, that would cost a lot. The R&D would cost quite a bit. And the time to market would be years. So with that proposition, of course, we have many unknowns. The other alternative was to find a VDI or RDP or desktop as a service platform to stream that existing Multiview application over the internet. So of course, with that, there would probably be very little or no coding changes at all. We would have a very low cost path. We would have a solution almost available immediately overnight, which was very advantageous to us, especially when you have clients calling and asking for that. And it pains a software vendor to have to turn away customers, as you know. And with that proposition would be few unknowns. So as we went down the path, we said, let's try to find the second option. Let's try to find a platform that allows us to stream or deploy that Windows application over the internet. And Multiview would host it. So the things that we compared when we looked out in the marketplace, we compared over 24 different platform services. Really, the first 4 listed there are user experience, video quality, mouse and keyboard responsiveness or feel. Printing is very important, especially for an accounting application. And ability to upload and download files from the local PC to the remote desktop. So those are all user experience, truly important for Multiview, which maintains a very high quality user experience through and through. We also looked at the cost licensing. We looked at how user management would work, infrastructure management. Now, when you look at other platforms, and some of, especially the traditional platforms that have been around for 2 decades, there is quite a bit of upfront cost, quite a bit of expertise required to manage those systems. And quite frankly, we did not have the expertise. And when we looked around, we didn't find anyone really that was going to be able to help us through that transition. We also considered maintenance of the platform, the scalability of it. Security is incredibly important, especially since a great deal of Multiview's business is healthcare based. We consider security primal, or one of the prime things that is very important to us. And of course, when you're selecting a partner, you look at the maturity of that partner. You don't want to select a partner, of course, that's been around for maybe only a year or 2 or in a startup phase. That exposes your company to risk, and we were trying to be risk averse. So through that journey of over 24 platforms, we selected AppStream 2.0. And AppStream 2.0, working with Morali and the rest of the AWS team out of Seattle, brought us to a very reliable platform that we built our business on over the last couple of years. And of course, with AppStream 2.0, you have a very fluid video stream. It feels better. Our customers have said, the ones that have transitioned from on-prem to cloud have said that the responsiveness and feel feels better through the browser when the pixel is being streamed to the user, as opposed to using the application natively on their own computers. And of course, that's true because we're using very powerful back-end servers to stream those instances. Multiview prints very easily with AppStream. We have very good, easy file upload and downloading. When a user is uploading a file, it's very easy to do so with AppStream. And conversely, downloading files to the local machine that are exported out of Multiview works very well with AppStream 2.0. And of course, with AppStream 2.0, there is no infrastructure for us to manage. It's all virtually done through the AWS Management Console. A company like Multiview that had no experience with AWS prior to this journey, bringing on migrating to AppStream was a very easy transition because the tools within the AppStream 2.0 GUI were very easy for us to use. And of course, there was no upfront cost. And some of the other traditional platforms to stream a Windows application over the internet required that upfront cost of buying that infrastructure. We, of course, did not have that. With AWS, we really go on this pay-as-you-go model. And we've been able to optimize our costs by committing to 2 or 3 year terms on the EC2 instances that we have running in the background. So that works very well for us in trying to keep our costs as low as possible to pass on that savings to our customers. And of course, because it's on AWS, we connect easily into back-end services. To illustrate that point to you, this is what Multiview does. We set up a separate VPC for each of our clients. So we stand up a new VPC, and within that VPC, we have all of our resources, and we break them into different security groups as well for enhanced security. And each channel there that you see where there's a connection being made is fully encrypted by AES 256 or SSL. So this model here allows us to separate each of our clients within one AWS account by way of the very helpful labeling and tagging that AWS offers. So our single AWS account has all of our client accounts in it, and we can see each of the different resources tagged properly. So it's very easy for me to identify what VPC is for what client, what EC2 instances are for what client, what AppStream resources are for what client. So it's all very easy to manage and maintain for a company, remember, that sold a traditional product in a traditional way and then shifted into this managed service provider where we host on behalf of our clients. So, of course, that's the Multiview journey on AppStream. I hope you got some value out of it. Thank you very much.
Thanks, Jamil, for walking through how you were able to SaaSify your traditional client-server application. The final big bucket of customers that we see are in the public sector and educational customers. If I had more time, I would have had a customer come up. Fortunately, we only have the time that we have. So we see in the educational space, customers are traditionally virtualizing their labs and classrooms. So if you think about in the education space, when you went through college, you had these large computer labs that were taking up space that you could have otherwise used for classrooms. We're seeing customers now replace those with AppStream. So students can use their Chromebooks, their MacBooks, whatever device they're coming to the university with to get access to the applications that they need in order to do their schoolwork. And you can now reclaim that physical lab space, get rid of all of those workstations that are in there, and make that into classroom space instead. And finally, online classrooms. So we worked with the Canvas team or the Canvas company to enable Blackboard and all these other things to integrate seamlessly with AppStream. So now, as part of the student assignment, they can just immediately launch into their AppStream session in order to use the application they need to provide to do their coursework. So how do you get started with AppStream? We have the AppStream Try Now. If you just Google for it, it'll take you there. If you have an existing AWS account, you can click on it and try some of our trial applications to get a feel for what the AppStream streaming experience is through your HTML5 browser. We have a simple getting started guide which walks you through the entire workflow from creating your VPC all the way to getting your fleet and starting streaming it. New this year are the next two items. The first one is the Isp Workshop, which is a set of code templates that you can use that'll teach you not only the AppStream workflow, but also the overall AWS set of services. So here's how you can use the AWS breadth of services to provide a full serverless environment for integrating a AppStream application within your web portal. The next one is more tailored towards enterprises for the enterprise application onboarding. So how do you use services like step functions, API gateway, Lambda, and all these other services to provide a web portal that enables your application owners to create and manage their own AppStream environment. We have deployment guides for some of the software that has been certified on AppStream. And you can follow our desktop and application streaming blog, which has a lot of reference material, customization guides, setup instructions, and other material like that. As well, we have a range of partners who are certified to deliver AppStream if you want to engage one of the partners. So this slide is kind of busy, but it's kind of exciting. These are all the things that we've launched in 2019. So I've talked about a little bit of it throughout, but we have a number of exciting features that we've launched this year. The big ones that I want to call out are really on compliance. So we're now HIPAA eligible, and we have PCI SOC 1 and SOC 2 and SOC 3 compliance for any of those workloads that you have. But otherwise, I'll just leave this up for a second so you can take pictures. I think the slides are also going to be released later, but these are all of the variety of features that we've launched this year. So we have a number of other sessions if you want to learn more about AppStream or other journeys. We have the GE Power story at 1:45 back here in the Bellagio, as well as for our sister service workspaces. You can learn how Carnival Cruise Line was able to migrate from their on-prem VDI environment into workspaces, and also how Facebook deployed workspaces for their use case. We also have a customer reception that's tonight. If you're all interested in hanging out with the service teams as well as our specialized sales and solutions architects. So this is open for everybody. There's no cost or anything like that. Just you need to RSVP by going to eucappsreception.splashthat.com, and it'll send you a meeting invite very quickly thereafter. Thank you all for your time this morning. We'll be hanging around for a little bit if you have any questions for us. But thank you.